Here we are estimating the sum of a series. Now suppose we have been able to use the integral test to show that this series a subscript n is convergent, and we now want to find an approximation to the sum s of the series. Now of course here it says any particular sum s subscript n is an approximation to s because the limit as n approaches infinity of s subscript n is equal to s. But how good is such an approximation? Now to find out, we need to estimate the size of the remainder. So r subscript n represents the remainder where you have s minus s subscript n, which is equal to a subscript n plus 1 plus a subscript n plus 2 and so forth. And you can see the figure here in figure 3 to the right. Now the remainder is the error made when s subscript n, the sum of the first n terms, is used as an approximation to the total sum. Now we use the same notation and ideas as in the integral test, assuming that f is decreasing on n to infinity, and comparing the areas of the rectangles with the area under the curve y is equal to f of x for x is greater than n. In figure 3 you can see that the following, we would get r subscript n, which is equal to a subscript n plus 1 plus a subscript n plus 2, which is going to be less than or equal to the integral of that function going from n to infinity. Similarly, we can see that from figure 4 that r subscript n is going to equal a subscript n plus 1 plus a subscript n plus 2, which is going to be greater than now the function as it starts from n plus 1 to infinity. So we have proved the following error estimate, the remainder estimate for the integral test. Now suppose f of k, which is equal to a subscript k, where f is a continuous positive decreasing function for x being greater than or equal to n, and the series a subscript n is convergent if the remainder r subscript n is equal to s minus s subscript n. Then we would have the following. We would say that the remainder r subscript n is in between the two integrals. On the left you have n plus 1 to infinity of that function. On the right you have f of x d of x going from n to infinity.